Hello everyone, welcome back to this channel. Today we are breaking down one of the most important topics in chemistry, that is types of chemical reaction. So today we are going to be talking about the 5 core types of chemical reaction. Let's get started. So yes, types of chemical reactions. There are 5 core types of chemical reactions. We have the combination reaction, the single displacement reaction, we have the double displacement reaction, we also have the decomposition reaction, and the last one, combustion reaction. So today we are going to be talking about all of these core types of reactions. So let's start with combination reaction. Yes, so the first type of chemical reaction we are starting with is combination reaction. So a combination reaction happens when 2 or more substances combine to form a single product. Let me read it again. A combination reaction happens when 2 or more substances combine to form one single product. Very simple reaction. So if we have a substance A and we add it to a substance B, for combination reaction we are supposed to produce a single product of both of them, A, B. So just think of it like marriage, okay? 2 people marrying to form what? One single family. That's a combination reaction. Very simple. Let's take some examples. So the first example, when hydrogen gas reacts with oxygen gas, we form one single product, which is water, H2O. Yes, which is water, H2O. Very simple. Another example also is when magnesium reacts with oxygen to form magnesium oxide. Very simple, as you can see. 2 products forming one product. 2 products forming one product. So for combination reaction, these are the key ideas you have to know to identify a combination reaction. First idea, combination reaction involves 2 reactants. Combination reaction involves 2 reactants to produce one product. Always combination reaction, 2 reactants, one product. And you should also know that in this reaction releases energy. This kind of reaction releases energy. This means combination reactions are exothermic reactions. Very simple. Now let's move forward to the next type of chemical reaction. So the next type of reaction we are going to be talking about is a decomposition reaction. So decomposition reaction is just the opposite of combination reaction we just learned. So a decomposition reaction happens when one compound breaks into 2 or more simpler substances. Now let's look at the general form. So AB breaks down into A plus B. Very simple. So anytime you see one reactant giving out multiple products, wherever you see a reaction where there is one reactant giving out multiple products, then you think of what? Decomposition reaction. Now let's take some examples. So one common example is CaCO₃. One common example is CaCO₃, calcium carbonate, breaks down into CaO, calcium oxide, plus CO₂. Very, very simple. Now let's take in the key ideas of this like we have been doing. So the key idea for decomposition reaction you have to know is in decomposition reaction there is one reactant giving out two or more products. And also in decomposition reaction it usually requires heat or electricity to break down. It usually requires heat or electricity to break down. That means if you want to break down a compound, you have to either apply heat or electricity to break it down into the smaller forms. Let's take our next reaction. So the next reaction we are going to be talking about is a single displacement reaction. So this is a very simple reaction. It's a reaction in which one element replaces another, or there's a swapping. Let's look into it. So this happens when a more reactive element replaces a less reactive element in a compound. Let's take the general form. So A plus BC is equal to AC plus B. So if you are very observant, you notice that this A here kicked the B out. It swapped with the B, it replaced the B, kicked the B out, took its position, and the B was left alone. So now let's take some examples to understand much better. So if we have zinc reacting with HCl, this reaction here is a single displacement reaction. Key ideas: one free element, one compound. If you study the reactivity series, you'll notice that zinc here is more reactive than hydrogen, meaning the reaction can happen. So zinc kicks hydrogen out. Then we have zinc chloride plus hydrogen gas. So as you can see, because zinc is more reactive than hydrogen, the reaction happened. Hydrogen was kicked out, zinc took its position. But if this reaction was between copper and HCl, from the reactivity series, hydrogen is more reactive than copper, because zinc here is very strong, it can beat hydrogen, but copper here can't beat hydrogen. Copper is less reactive than the hydrogen. So in this case, no reaction occurs. Very, very simple here. Very, very simple. So now let's take our key ideas. So first key idea is, in this reaction there is one free element. As you can see, there's always one free element just there on its own, and there is one compound. There's always one free element and one compound. one free element. Okay, and in this reaction there is swapping. And then most importantly, reaction depends on the reactivity series. Good. Now let's take our next reaction. So the next one we are going to be talking about is a double displacement reaction. Just like the single displacement reaction we just talked about, is also swapping pattern, but in this case 2 compounds are swapping partners. This happens when 2 compounds exchange ions. Okay, now let's take the general form. AB, one compound, plus CD, another compound, swap partners. So A first person goes with the last. AD plus first goes with the last. AD, the first here also goes with the last here. CB. Now let's take a few examples. Okay. So silver nitrate reacting with sodium chloride. So now this is a double displacement reaction. So the first goes with the last. We have silver chloride plus the first here also goes with the last here, forming sodium nitrate. Now let's take our key ideas as always. So 1, it involves 2 compounds. There is ion exchange. These are ions, H plus, Cl minus exchange, ion exchange. And also, this kind of reaction usually happens in a solution. And often forms a precipitate. Water or a gas. Now let's move on to our next and last reaction. The next and last reaction we are going to be talking about is combustion reaction. So this reaction happens when a substance reacts with oxygen. That is all. Any reaction that involves a substance A reacting with oxygen is combustion. Any reaction where a substance reacts with oxygen is called combustion reaction. Now let's take very simple examples. Now magnesium reacts with oxygen. This is a combustion reaction. So as long as we are reacting it with oxygen, it is a combustion reaction. So as you can see, magnesium is a combustion reaction, at the same time a combination reaction is common. Now let's take another example. CH4 reacting with oxygen gas. CO2 plus H2O. So as long as the reaction involves oxygen, as long as you are reacting something with oxygen, a substance with oxygen, then it is combustion reaction. Now let's take our key ideas for combustion reaction. 1. Combustion reaction involves oxygen. Very important reaction. It involves oxygen. 2. Combustion reaction produces heat. Combustion reaction produces heat. It always involves oxygen. It produces heat. And one thing you should also notice that anytime you hear burning, the first thing that should come to your mind is combustion reaction, because we need oxygen for burning. Oxygen is needed for burning. So if I say magnesium is burnt, the first thing that should come to your mind is what? Combustion reaction. We are talking about this reaction. So very, very simple. So in summary, we have 5 core types of chemical reactions: combination reaction, single displacement reaction, double displacement reaction, decomposition reaction, and combustion reaction. If this video helped you a lot, if you benefited a lot from this video, please like and subscribe and also share. Thank you for watching.